Good afternoon. This is Zach Zaharowitz of the Lighting Quotient, head of the applications group here, and I'm joined by Paul Ford, vice president of design and head of our product development group. The purpose of this webinar is to discuss our new high lumen style S136, as well as touch on how it relates back to the high lumen S104 that we launched last January. In terms of housekeeping issues, if you take your cursor and hover near the top of the screen, you should get a Zoom meeting drop down, and one of the choices is Q&A. You can utilize the text box where you can type in questions, and at the end of the webinar, we'll try and look through those questions, find common themes, and answer those as best we can. Also, we're going to be turning off our video to just improve the overall quality of your viewing of the slides. So we're going to disappear shortly.
Turn it back on at the end.
Yes, at the end we will be on also to show you a couple of the samples we have here in the room with us. So Paul will kick things off.
All right. Thank you, Zach. And you just have to click on the screen. So we're going to talk about the new Elliptipar S136 LED. Over the past few years, you've seen the LED product line expand quite a bit. And last year when we introduced the S104, it was available in three sizes, a 12-inch, 7-inch, topped out about 7,300 lumens. So what we've come up with now is getting more powerful. We're going 36. And the new S136, it's still an asymmetric LED, asymmetric distribution. It's for wall mounting for output. Now we're up to 24,800 lumens delivered. Still using the patented fractor metric throw and lateral distribution, so we can go further on center. Adjustable, lockable aiming, so you can aim the fixture and lock it in place. We're using constant current drivers. They're universal voltage, 120 through 277, including some of the dimming options as well. With this product, and it also applies to the 104 now, we're able to offer 347 volts for Canada. Mounting options include surface mounted, wall mounted surface, or pendant mounted for uplighting. And we have a natatorium option. As far as the color temperatures, we offer 2700 through 4000 at 70 CRI, 80 or 90 minimum. So they're 70 plus, 80 plus, 90 plus. So we also offer, there are other color temperatures and CRIs available. This is on the Lumen Luxion ZES platform. So there are additional color temperatures available in CRI. So don't be afraid to ask for those. It's just we've narrowed down the catalog. And with this LED platform, we are able to enjoy a L90 or 90% lumen maintenance for greater than 60,000 hours per TM21. The S104 designed using Elliptipar external redesigned to house a light engine as well as the drivers. This topped out about 500 milliamps to keep the LEDs and the driver temperatures in check. With the 6 now, the design we borrowed from the ovolinear design that you probably remember from the 4X fluorescent days. And now we're putting the drivers into the ovolinear box. And what this allows us to do is drive the LEDs at 625 milliamps, so we're getting a higher light output. It also puts the drivers in a more accessible location. So if you ever have to change a driver, the housing, and do access to drivers to replace them. This is an overlay of all the S104 and S136 offerings, and you can see the wide variety of lumen packages available. This is actually just representing the 4000K70, but you can see the length is in the first column. We have 12, 17, 24 inch, and then the 136 starts at 24 inches again, but now we're driving it at 625 milliamp. and then we have a 32 and a 39-inch length at 625. This is just a quick look at the catalog page. It is available online now, and I'll take you through, highlight some of the specification options. The first is the light package, basically the drive current and number of LEDs. So the lamp itself consists of the drive current and the number of LEDs. So 6108 operates at 625 milliamp, and there's 108 way to 80, which is our 39-inch fixture, which has 180 LEDs driven at 625 milliamp. All of the catalog pages have a link where it says click here.
Here.
Oh, okay, I jumped ahead. So the mounting options are S, X, and 1. S is surface mounted for wall mounting. The X mount is used with the cantilever accessory, which is actually in a pendant orientation for uplighting, and it's really for the 24-inch units. And then the cluster assembly, the VPR, is the single stem pendant. So this is a view of the S mount. Here's a quick view of the cantilever being used as a pendant, and again, it's only for the 24-inch long fixtures. The length of that is 36 inches, but we have done custom lengths a little bit longer. It just depends on the situation, but the best choice is typically the VPR pendant, which can be used with any of the 3-size fixtures. It is available with a natatorium option in both a straight pendant as well as a swivel pendant for slope ceilings. We did submit both one-way and a two-way, so we should be the two-way back-to-back version of this in the next few weeks. The bolt option has been simplified. It used to be 1 for 120, 2 for 277, but now since most of the drivers, pretty much all the drivers we use are dual voltage or universal voltage, we've come up with the 8 voltage code, which is non-dimming universal voltage 120, 277, M voltage for dimming. We're also we'll be adding the 7 voltage codes in the next few weeks. This is where we have a link to all the driver information. The document opens up as a PDF, and it includes information about all of the drivers that we use, as well as remote distance and minimum starting temperature. The links on the PDF itself will take you to the specification page for each of the drivers. Now you can see this is at Rev N, so this is constantly being changed and updated as new drivers become available. Our options, the fixture comes standard with a cutoff visor, all mounted and it's uplighting, and you will need a visor most of the time. Zach will show a few examples where you might be able to get away without it. And then the VP option is for the indoor pool or natatorium use. The main difference for the natatorium is that we seal all the cord exits going into the head assembly so that the LEDs are not exposed to any moisture or condensation. Color temperature and CRI options, as I said before, 2700 through 4000 Kelvin, with options in 27 and 3000 for 90 CRI and 4000 K for 70 CRI. The dimming options for the 136 include dimming, which is just 10 analog dimming. There's 00, which is non-dimming, but there's ZX for 0 to 10 dimming. That dims to about 5%. We also have 2 eldo LED dimming options. One is for 0 to 10, but that actually dims, basically dims to off, and it's a premium dimming driver. And also the eldo LED dolly version of that same driver, which allows you to have addressable drivers. As far as the construction, as you would expect, it's all extruded aluminum for the heat sink housing and enclosure. We use all stainless steel hardware. We use stamped aluminum sidearms, die-cast aluminum end plates. All the gaskets are silicone. The finish is statically applied baked polyester powder. It's an enamel finish, very rugged and easy to clean. Standard on the catalog page is just semi-gloss white, but of course we can offer it in any of the RAL colors, as well as if you have a sample chip that you want to send in, we can computer match that. We also have a clear microprismatic tempered glass lens for high light transmission, and it is impact resistant. It has a microprismatic pad to soften the beam. Extruded aluminum door frame with mitered corners, fully adjustable aiming, and it has a locking set screw so you can lock that aiming. We have also added to the end plate casting an aiming indication so that you can have all the fixtures aimed at the same mark and locked in place. All of the light engines are serviceable for replacement or future upgrades, so they are accessible. This is an exploded view for, typically these are done for the factory just to show how the assembly goes together. Now Lumen maintenance, this is where we're talking about the LEDs themselves and how they perform in the fixture. The first report I'm bringing up is a typical LM80 report, which is furnished by the manufacturer of the LED. In this case, it would be Lumileds. And what's nice is that they have 10,000 hours of data. And that's important when we get into the TM21 report. So the LM80 is from the LED manufacturer, and then that gets used with the in situ test that we send our fixture to a third party. In this case, it was UL. They will allow the fixture to come up to full temperature. They'll take measurements on the driver as well as the hottest LED, and that gets correlated together with the LM80 data and the in situ temperature. We put it into the Energy Star TM21 spreadsheet, and it will calculate either L70, L80, whatever you would like. In this case, we asked it to calculate L90, which is 90% of lumen maintenance to, or 10% reduction in light, and that's going to happen well past 60,000 hours. The reason it's 60,000 that per TM21, you're not allowed to report more than 6 times your actual test data. So that 10,000 hours of real test data is what allows us to claim greater than 60,000. Now above that, 50,000 hours, and that's just showing what is the lumen maintenance going at that time. That comes from the lighting facts label. They typically ask for 25,000 or 50,000. So you'll see that value on the lighting facts label. And on our catalog pages, this is where you'll see the L90 10K. The 10K stands for how much data has been actually measured, and greater than 60,000 hours per TM21. Now, if we switch over to the website, if you go to click on products and click on the quick find, it will bring a dialog box. You can type in, if you type in S, it will bring up all of our LED products, all of the Elliptipar LED products. If you type in S1, it'll bring all the surface mounted up. S2 would be recessed, S3 would be cove light. In this case, I've typed in S136, it brings me right to the product. And this is where I can open up the data sheet, which we looked at before. And it opens up in a PDF format. I can also access the product fact sheets. And these are the cell sheet, which is a two-sided cell sheet with a color photograph of the product on the front. On the back, there's cross-section as well as performance curves and features and benefits. We also have scaled performance tables, which this is helpful when you want to find out exactly how many lumens are being delivered, not only for the 3 different size fixtures, but all the different color, temperature, and CRI, which you can see there is quite a difference. Just looking at the first, the 24-inch fixture with 2700 Kelvin 90 plus CRI is 9955, and it goes all the way up to 14,898 when it's 4,000 K70. So there is a large difference, and it's just inherent in all the LEDs. The cooler the color temperature, the lower the CRI, you're just going to have more light output. The lighting facts label, you'll have access to that. And this is where that 94.93 came in, where it's Lumen maintenance projection at 50,000 hours. We also have, this is fairly unique, we have TM30 reports. TM30 is the new color metric that the IES has put forward for evaluation. We've included all the TM30 reports for our LEDs online. It's a 7-page report. This happens to be, I'm just opening one of them, that says 2700 Kelvin 90 CRI. The first page is a summary report, which gives you the, at the top you'll have R sub F value and an R sub G value. And R sub F is the fidelity, which is it's most similar to what we all know as CRI, but it's evaluated over 99 samples rather than CRI, which is only evaluated over 8. The R sub G is the gamut or the saturation, and that's really best shown in these circular diagrams where when it goes outside of the circle, that's showing you which colors the LED tends to be able to saturate. The next few pages are just a little bit more in depth. This is the R sub F value for the TM30 value, and also the CIE R sub A or CRI value. And you can see there will be a difference between the two because of them, because one is evaluated on 8 colors and the other on 99. This shows another value which may or may not take off and be used is it's called R sub skin, which is they'll evaluate the colors that render skin tones. So the TM30 has not been adopted by the IES yet, or by the CIE, I should say. The IES put it out there sort of to kick the tires, get people to look at it and evaluate it and see if they like it. This page is showing the 99 color samples, and each block is actually two samples. The left half is what the reference sample would how it would show that color under a reference source, and then the right half would be under this particular source. And the left just shows kind of the score for all 99 colors. So it's something that may or may not get adopted by the CIE, but it is good to take a look at that and start using that. I'm going to let talk to you about the photometric files.
As far as application, certainly if you're working with someone, they would like our group to look at something in terms of a calculation, we're more than happy to do that. But naturally, there are a lot of designers who want to access IES files, or in some cases actually go back and look at the original reports. In that particular case, we do have posted, and we're still tend to say IT, in this case, was generated by UL for the style 136. But if somebody does want to check out that PDF, it is available, and that gives them access to all the original information from the test, including some of the color data, candle power curves, lumen distributions, and so forth. Again, while we're happy to do calculations, many people will be using a program like AGI or other software, and if they want access to the IES files, we've tried to simplify their lives from the standpoint of not having to take only one photometric report and then factor it umpteen times based on the CRI and CCT selection. So while Paul showed you that scaled performance table, which is a great way to at a glance evaluate how choosing one color temperature or CRI ranking will influence lumen output, what we've done is take each of the 3 fixture lengths and place them under each particular color. So as an example, if you went into this table and made the top selection, you would get a zip file that contains 3 IES files, all assuming 700 Kelvin, 80 plus CRI, and representing each of the 3 fixture lengths. LEDs, 144 LEDs, and 180 LEDs. If you realize clients asked me for 90 CRI, you could exit and then select the zip file for 27K 90 CRI. Just trying to make it a little bit easier so that users of this information aren't having to always on the fly factor each of these reports. For anyone who might be using Revit, there are some BIM files available for the 136. It's contained in one zip file, which would then get you this type of 3D embodiment of the fixture. If any of you are big fans of Revit or work with clients that use it often, there are different packages. You'll have MEP consultants using one package versus architectural customers. And what we've done is use what they call their face-based tech. It's just it's sort of a common language where it allows an engineer, for example, to place it in their version of the master file and have the architect do the same, because there are some slight idiosyncrasies or differences between how the architectural package works and the MEP package. If you have any other questions on those objects, again, feel free to contact our applications group, and Ellen Tweed in particular is a wealth of information on that subject. Also, we get asked about installation files, not only by installers, but designers will frequently contact us saying, can you tell me how this mounts, because I have an structural situation and I need to see if this might work the way I think it will. So those installation files cover a range of examples. One of the ones posted typically takes care of that driver information Paul described. There are also things in driver replacement and light engine replacement. Some of these are common across multiple products. Some are specific just to the 136. In this case, you're seeing a sheet that's showing light engine replacement on the style S104 and the outdoor S172.
That one's actually driver replacement.
Sorry, driver replacement. This is getting into the gritty on the quick connects and being able to separate the connection and then remove the light engine when you're doing that type of replacement, either for future upgrade or something more immediate. And then there are the more I guess you'd say recognizable type installation sheets, in this case showing the S-mount S136, how the extruded mounting plate first goes up on the wall, how the rest of the unit then hooks onto and hinges from that wall plate, stays in an open position while the wiring connections are made, then hinges shut and is secured. And assuming we have a couple minutes at the end, we actually have a cutaway sample of style Paul can show that. And finally, the pendants, which projects like a natatorium frequently come up as a way of getting the fixture closer to the edge of the water area, and we have installation sheets of those types of trees. Just to dive into the VPR in a little more detail, Paul showed the catalog sheet which mentioned straight versus so-called swivel or hang straight, as well as what we'll call standard versus natatorium, which involves a few hardware changes. I also wanted to point out you can use the either over power feed or with direct conduit by selecting the correct letter code. The drawing you're seeing here is relative to the straight pendant stem, but what we'll call the swivel comes up frequently. However, keep in mind it's not swivel in the sense that it just hangs loose. What this accommodates is, say, a pitched ceiling deck in a natatorium where you need to compensate for perhaps a 5 or 10 or 15 degree slope. The actual detail allows the final plumb positioning to be into place, stays plumb. But these types of applications and situations come up frequently. In terms of applications and lumen output, when we announced the S104 a year ago, the 12-inch size, the 17-inch size, and the 24-inch size gave us 3 ranges of lumen output that were roughly akin to the traditional 300 watt to 500 watt halogens, or on the metal halide side, the 12-inch was quite like the 70 watt ceramic metal halide in either the warm or cool colors. The 17-inch was much like the 150 watt ceramic metal halide, again, in either the warm or cool selections. And then at the bottom, I'm showing a warm 210 watt Philips Elite versus a 4K 40,000 lumen 250 watt pulse start lamp. If none of these numbers look exceptionally familiar, it's because these aren't the rated lamp lumens. These are actually rated lamp lumens times the traditional luminaire efficiency. So we really are trying to compare here delivered lumens from that luminaire versus delivered lumens from the LED products, which are now reported that way. As far as applications, we beg of you, as projects you're involved with get completed, if you see something that looks attractive to you and to your specifiers, please let us know, because we accumulated so much photography over so many years of elliptic and traditional sources. We need to do that rapidly in the LED world. So for purposes of this slide, I've borrowed images of some fairly recent projects, again, just to show types of spaces, volumes of space, and the types of applications where the S104 might fit. The example on the left is the B&O Railway Museum, which was using 70-watt ceramic metal, which would be much like a 12104. At the center and to the right, these were all 3 150-watt ceramic metal halide projects for an elementary school, the Utah State in Jackson Hole. So in that case, the 17-inch S104, depending on the preference for color temperature, would fit just as well in those types of applications. Some of the scout shots that we have, again, these aren't professional photography, but we did get scout shots of a couple of projects I wanted to share. The first is a corporate conference center, which had sort of a unique barrel vaulted ceiling. So they used a series of the 12-inch S104s with dimming drivers along the center of the space to provide some indirect illumination and just to enhance that ceiling form. Paul alluded to this one earlier. I wouldn't typically recommend using an uplight or ceiling washer without a visor. And I have to admit, not knowing the full history here, whether they thought they were ordering a wall washer or a ceiling uplight. But what you have here is one of these unique situations that come up where they were able to position these lights behind this ornamental wall and in an area where the public doesn't normally go, position these. So yes, they serve to uplight and wash across the ornamental ceiling, but they were able to position them so that beam distribution also covered that opposing wall. So in a sense, they were able to get 2 for 1 here, having one group of fixtures like both the ceiling and the vertical surface. And in terms of something just pulled from an AGI model, when we get into the 24-inch length, we often start to look at taller, larger spaces, whether it's an atrium or something of that nature. Moving over to the one, and finally, I just wanted to point out, even for swimming pools, I would say a rec pool with maybe a 30 to 50 foot candle requirement and a lower ceiling deck that's clean, meaning poured concrete, 16 feet in height. We've also done layouts using the 24-inch S104 for those types of spaces. Now moving to the S136, just to reiterate sizes, 20, 32, and 39. And not that many of you are probably considering sources for projects these days, but I will point out the 32-inch length and the 39 are to the 1,000-watt and 9 sources that we used to use in some of the very large houses of worship. And in fact, we're seeing some of those projects come back to us now, where the people who originally designed them are coming back, or the agents who originally handle those projects are coming back saying, what do you have as an alternative that'd like to refit this installation, go with the same location, same fixture, appearance, switch to LED. On the halide side, you can see those 3 lengths. In the shorter length are comparable to either a warm-colored 210-watt Elite or a 320-watt Pulse Start. The middle length is very comparable to the 350-watt Pulse Start, and in the longer length, we're comparable to a 315-watt Philips Elite in the 3K or a 400-watt Pulse Start in the 4,000 Kelvin. Just again, as images rather than actual project shots, what you see here are a variety of things, a high school atrium that used either 250 or 400-watt metal halide. Airport used 315-watt Elite in a warm color, so again, that's something we could now do with LED in the same color temperature. And the library reading room and the corporate gym center were both projects that had used 400-watt metal halide. So that would be something now within our capability with the 39-inch length. And on the pools, there are some things like NCA, competitive centers with very, very high foot candle requirements. But for even a pool that's looking for 50-foot candles and has a moderate deck height, something in the low 20s, 20 to 24 feet, that's now also within our reach, looking at the 39-inch units in some pendant-mounted arrangement. So once again, a recap of the overall launches that you've seen, and most recently on the subject of high lumen, the S104. We are at 1:30. If you can hold on a second, we'll open the Q&A to see if we have any questions. We don't. Here a couple of things that came up this morning. There was a question about non-dim versus 0 to 10 volt, and in this particular product, we're essentially using the same drivers. I made the point that's not necessarily true again across all product lines, but in this case it is. There was a question about the ambient temperature, and somebody pointed out in an natatorium some temperatures, that's true, but Paul just why in the testing report the 25C was used as the reporting temperature. If you have any questions you think of after this presentation, feel free to Paul Ford or myself. Here you see our email addresses, or if you don't have our direct lines, feel free to call the main number and just ask for either of us. And if you'd indulge us a bit further, go back to the video, briefly show you physically the relative scale of a 104 and 136, which we have here in the room. And Paul can also show you that hinge on the driver compartment.
All right, well, I guess we should show you this is the 104 you're familiar with. That's the 24-inch unit.
So again, everything contained within the Elliptipar cross-section, drivers and light engines alike.
And now we have the, this is the 39-inch S136, where the drivers are located in the oval-linear compartment. And I'll just show you a cross-section from the box itself. This is a cutaway from an older product, the 4X product line. But just to show you, the wall plate is a small section of it would mount to the wall. You'd have the hinge at the bottom. It hinges and hangs open, so your hands are free to wire. Once it's wired, it hinges shut, and then you'll have the screws to hold it closed. So it's very easy installation, very simple. And I think that's it.
So we thank all of you for attending. And again, if you think of any questions, feel free to contact Paul or myself. Thank you.
Thank you.